Lesson 11.2.2, Solving Inequalities. To start this, we're going to look at an example. Mr. Lawson bought a car for $16,000. Each year, the car loses some value. If the value W of the car X years after he bought it is modeled by W equals negative 1,500X plus 16,000, we should be able to calculate when the car will be worth less than $11,500. The graph of the model is below. So first of all, the model is this equation. Notice that that is a linear equation. The slope is negative 1,500 because that's the number that's being multiplied by x. So we can see that this line that they have for the model is the line that is going down and to the right. That's how we recognize a negative slope. In this graph, we have the horizontal axis measuring years. That goes from 0 to 11. And then we also have a vertical axis that is measuring worth of the car. That is going from 0 up to 18,000. And then right below the graph, we have this. The horizontal line, y equal to 11,500, that's the line that is just going straight across horizontally. If you want, you can write the equation next to that, y equal 11,500. That represents our threshold. We want to know when the value of the car will be below 11,500. Number one, use the graph to answer the following. Part A, in how many years after the purchase will the car be worth 11,500? Remember that the diagonal line is measuring worth at any time after the car was purchased. So if you were to put your pencil on that diagonal line and follow it, you would see that eventually, if you go all the way down to the bottom, the car will be worth nothing. But at some point, it crosses the horizontal line. If you put a point there, we're using the graph. So in how many years after the purchase will the car be worth $11,500? Well, where that diagonal line crosses the horizontal line, if you follow it down, it looks like it's at 3 years. So after 3 years. We've seen how to do this before. We've used graphs to make estimations. We just did it again. Part B. During which years will the car be worth less than 11,500? Well, the moment that 3 years has passed, it's worth $11,500. And then any time after that, the car will be worth less. So the car's price is always decreasing, or the worth is always decreasing. So anytime after 3 years, the car will be worth less than 11,500. So the worth is less than 11,500. So as long as our number of years is greater than 3, then the worth of the car is going to be less than 11,500. So now let's look at another example. Ms. Nizami loaned $10,000 to a startup company. Under the terms of the loan, the company will be charged interest during the first 12 months, but will not have to make any payments until the start of the second year. The equation for the amount of money, capital A, that the company will owe Ms. Nizami at the end of X months is 10,000 plus 120X. We want to know when the company will owe less than $10,600 on the loan. The graph of the model is below. So again, the model that we have is capital A equals 10,000 plus 120x. Notice that the slope here is the number also being multiplied by x, but it's positive 120. which means that the diagonal line is showing a positive slope. It's going up and to the right. Here, the horizontal axis stands for months. Notice that it goes from 0 to 11. The vertical axis is the amount owed. It goes from 9,500 at the bottom up to 11,500. And then right below the graph, we have number 2. Use this graph to answer the following questions. Part A, how many months will it take until the company owes $10,600? Notice here they're using $10,600 like a threshold, like in the previous example. And you can see that there's a horizontal line here, and it's between 10,500 and 10,750. So this is that horizontal line, y is equal to 10,600. So when or how many months will it take the company to owe 10,600? Again, notice where the diagonal line crosses the horizontal line. And where that happens, if you follow it down to the horizontal axis, you can see that it looks like it's 5 months. So, 5 months. Part B, during which months is the amount of money that the company owes less than $10,600? Explain your reasoning. So, first of all, notice that this diagonal line starts at 10,000. That's its initial value, initial amount that's owed. And it's below our threshold right until we reach their intersection point. So, before 5 months has passed, the amount owed is less than 10,600. Okay, so now from these examples, let's take some next steps. Number 3. To help you visualize the relationships between the numbers, label the number line below with numbers from -7 to 7 in increments of 1. So we're going to start building some understanding of inequalities that will relate to those examples we just looked at. We're going to return to those in a little bit, but we're going to lay down some groundwork. So first, here's a horizontal axis just representing a number line. This is just the way you might have introduced yourself to a number line when you first learned arithmetic. So they want us to label the number line with numbers from -7 to 7 in increments of 1. So the first slash that I see there, I'm going to put a -7. And then if I increase by 1, that becomes -6 for the next mark, then -5, etc. At some point, we're going to reach 0, and then I'll be in the positive numbers. So 0, and then 1, 2, 3, 4, 5, 6, 7. So there we go. If A is a number to the left of B on the number line, then that means that A is less than B. So for example, since 2 is to the left of 5, you can see that. I'm circling 2, and that is to the left of the number 5. Then we know that 2 is less than 5. So this is the symbolic version of the phrase 2 is less than 5. So now let's perform some operations on some original inequalities and see what happens. And then it says, be careful because some inequalities may change. So let's start in the first row where the original inequality says 4 is less than 6. Now let's take both of those numbers and let's multiply by 4 in the next column. So what is 4 times 4? It's 16. What is 6 times 4? It's 24. Okay, so now we started with an inequality, 4 is less than 6. And that's true, because 4, according to our number line up above, is to the left of 6. And then we get an inequality. 16 is less than 24. Is that true? Yes, 16 is less than 24. Okay, so now what if we start with that original inequality, 4 less than 6, but now let's multiply both numbers by negative 3. So 4 times negative 3 would be negative 12. And then 6 times negative 3 would be negative 18. So now, would I also still have the first number less than the second number? No, that's not true. In fact, negative 12 is greater than negative 18, which means my inequality has to be pointed in this direction. Negative 12 greater than negative 18. So negative 12 is greater than negative 18. Remember, they said, be careful, some inequalities may change. So if you notice the original inequality, the inequality sign has a point to it, and it's pointing to the left. On the new inequality, after it changed, the point of the symbol is now pointing to the right. We had to change the inequality. All right, now let's go to the next column. Divide by 2. What's 4 divided by 2? That's 2. What is 6 divided by 2? That's 3. Would my inequality point in the same direction as the original inequality? Yes, because 2 is less than 3. What if I divide by negative 2? 4 divided by negative 2, that's negative 2. 6 divided by negative 2 is negative 3. And now take a look at our number line. Is negative 2 to the left of negative 3? No. So then I wouldn't say that negative 2 is less than negative 3. I would say the opposite. Negative 2 is greater than negative 3. Okay, now let's continue with the rest of these rows. So in the second row, negative 2 is less than 4. We can see that that's true from our number line up above. If I multiply both of the numbers involved, negative 2 times 4 is negative 8, and 4 times 4 is 16. And negative 8 is definitely less than 16, because a negative number is less than a positive number. So now what happens if I multiply the numbers in the original inequality by negative 3? Negative 2 times negative 3 is 6. 4 times negative 3 is negative 12. Is positive 6 less than negative 12? No, it's greater than. All right, what if I divide by 2? Negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. Negative 1 is definitely less than 2. And then finally divide by negative 2. Negative 2 divided by negative 2 is 1. 4 divided by negative 2 is negative 2. 1 is a positive number that's greater than a negative number. Are we starting to recognize some patterns? Let's do this one more time with the last row. The original inequality is negative 6 is less than negative 2. That's true from the number line we see up top. Negative 6 is to the left of negative 2. Now let's multiply by 4. Negative 6 times 4 is negative 24. Negative 2 times 4 is negative 8. Negative 24 is definitely less than negative 8. Now let's take our original inequality and multiply it by negative 3. Negative 6 times negative 3 is positive 18. A negative times a negative is a positive. Negative 2 times negative 3 is positive 6. 18 is greater than 6. Now what if we divide by 2? Going back to the original inequality, negative 6 divided by 2 is negative 3. Negative 2 divided by 2 is negative 1. A According to our number line, negative 3 is to the left of negative 1, so negative 3 is less than negative 1. And then finally divide by negative 2. Negative 6 divided by negative 2 is positive 3. Negative 2 divided by negative 2 is positive 1. 3 is greater than 1. So now in number 5, we are going to summarize the pattern that we just observed in the table. And what I want us to focus on is, when did the inequality change? And when did the inequality stay the same as what it was in the original inequality? They say, hint, use the words preserved and reversed. Preserved means that things stayed the same. Reversed means that they had changed to the opposite. So part A, when an inequality is multiplied by a positive number, its direction is, what is it, preserved or reversed? Well, let's take a look at the original inequalities. Notice that the 3 original inequalities all had the point pointing towards the left. It had a less than symbol. When we multiplied by positive 4, notice that they all stayed the same direction. So the direction, when multiplied by a positive number, is preserved. But now what about when we multiplied by a negative number in part B? Notice the ones that I have in the middle column that are in red. The inequality symbols reversed. They changed. Part C, when an inequality is divided by a positive number, again, the original inequalities, the points are pointing to the left. When we divided by negative 2, where I have them in green, those pointing to the left still, so they are preserved. And then finally, part D, when the original inequality was divided by a negative number, negative 2, the direction was reversed. So when an inequality is divided by a negative number, its direction is reversed. So what we're seeing is, if you are multiplying or dividing by a negative number, the direction of the inequality is reversed. If you multiply or divide by a positive number, it stays the same. This is going to help us then with solving inequalities. So just like equations, inequalities can have variables, and we can solve those inequalities. Solving inequalities is similar to solving equations. We can add, subtract, multiply, and divide both sides by any number, except 0. We are not allowed to divide by 0. Be careful though. If you multiply or divide an inequality by a negative, the inequality changes direction. It reverses to the opposite of what it was. So let's see that in number 6. Solve the inequality 4x is less than 12. And what I want us to do is think of an equation. So if we had 4x, instead of less than 12, just equal to 12, what would we have done in the previous section to get x all by itself? You have 4 times x. You have to do the opposite. So what's the opposite of multiplication? It's division. We need to divide by 4. So that's what we would do. We're going to do the same thing in number 6. To solve, divide by 4. So 4x less than 12, I'm going to divide the 4x by 4 and the 12 by 4. I'm doing division by 4 so that the 4 goes away, and all I'm left with is just the x on the left-hand side of the inequality. And then 12 divided by 4 is 3. I divided by a positive number, so the inequality is preserved. Same direction. Okay, so I didn't change that direction. So x less than 3 is the solution to the inequality. And that solution, this is now in number 7, that solution to question 6 is actually a collection of many, many numbers. In fact, an infinite number of numbers. On the number line below, shade the region that represents the solution to question 6. If the endpoint is included, it should be shown with a closed dot. If the starting number is not included, it should be shown with an open dot. So to do this, I'm going to label my axis just like we did before. -7, -6, -5, -4, -3, -2, -1, then 0, 1, 2, 3, 4, 5, 6, 7. So now let's find the number 3. So the number 3 is a positive number. And we want to think that solutions to the inequality are all values that are less than 3. So numbers that are less than 3 have to be numbers that are to the left of 3. So it would be all of these numbers that are to the left of 3. And notice how there's an arrow pointing to the left. It means that this just continues forever, off the page, forever, always to the left. But we don't need to write all of that stuff. The graph tells us that by that arrow. So now the only question left is where this starts is at the number 3. And the question is the number 3 included? So is 3 less than 3? No, that doesn't make sense. 3 is equal to 3. So the solutions have to be anything that is less than 3. So that means this is getting an open dot. We're not including the 3 in our solution. An easy way to spot that from the inequality is if you don't see a horizontal line underneath the inequality, it means you aren't including the number. So we don't have a horizontal line beneath the inequality. Okay, let's look at a few more now. Number 8, solve and shade the region that represents the solution on the number line to -5x is less than 30. So how would we solve this? -5x is less than 30. I need to get rid of the -5. Remember that -5x means -5 times x. I have to do the opposite. I have to divide by -5. Okay, so that makes the -5 go away from the left side. I'm just left with x. 30 divided by -5 is a -6. But now, because I divided by a negative, what do I have to do with the inequality? I have to reverse it. So if it was pointing to the left, now it's pointing to the right. So now on my number line, I can label -7, -6, etc. I can find -6. I can see that the inequality doesn't have a horizontal line beneath it, so I'm going to put an open dot at -6. And then if this says x is greater than -6, notice that that means now I have to shade to the right, because numbers that are greater have to be to the right. You also get a clue from this because when you write x and then have an inequality, just look at the direction of that inequality. If x is first and then the inequality is next, you can see that this inequality is pointing to the right. That gives you another little clue. Okay, number 9. Solve the inequality and graph the solution. Now we're doing a little bit more. So, -3x plus 7 is less than 46. Think back to when we were solving equations. You want to get all the constants, things without x, on one side first, before we start doing any division or multiplication. So I would actually want to move that 7. If you notice, the sign right in front of the 7 is a plus. I have to do the opposite of that, so I have to subtract 7. That leaves me with -3x on the left-hand side. I'm just adding. I'm not doing any multiplication, so I'm not going to change that inequality. Adding and subtracting doesn't change the inequality. Only multiplying and dividing do we have to think about that. 46 minus 7 is 39. So now, what would I do to get x all by itself? I have to divide by negative 3. That leaves me with x. 39 divided by negative 3 is negative 13. I divided by a negative, so I have to switch or reverse the inequality symbol. So x greater than 13 is my solution, and now we have to graph that. So you don't have to keep using the same scaling starting at negative 7. We can now play around with this even a little bit more. How about we start our scale down here with negative 15, negative 14, then there's negative 13. And then we know that we're increasing by 1 to the right. So I'm just going to put a circle at negative 13 because I'm not including it. And then since I have x is greater than negative 13, I have to shade to the right. And then finally, number 10, solve the inequality and graph the solution. 5x plus 7 is less than 8x minus 11. So this is just another step in the inequality solving process. So I'm going to start with writing 5x plus 7 is less than 8x minus 11. And I want to get the constants on the right-hand side. I'm going to make a choice. I want the things that aren't attached to x to just be on one side. So I'm going to move the 7 by subtracting, because that's the opposite of plus 7. All right, I'll do that first. 5x then is left on the left-hand side, less than 8x, because nothing's happening to the x's on the right-hand side. And then negative 11 minus 7 is negative 18. Now I need a little bit more space, so I'm going to go to the right margin, and I'm going to write again what I just left off with. You can see that having some extra scratch paper would help here. Now I want the x's to all be on the left side. So the x's on the left, constants on the right. That means I need to move the 8x. Notice that the sign in front of the 8 is a plus, so I have to subtract 8x. This is again just like what we did with solving equations. 5x minus 8x is going to leave you a certain number of x's, and it's just 5 minus 8, which is negative 3. Again, I've only been doing adding or subtracting, so my inequality has not changed. So now I have negative 3x is less than negative 18. And so now what's my last step? I have to divide by negative 3. So if I divide by negative 3, negative 3x less than negative 18, divide by negative 3, that leaves me with x is now going to be compared to positive 6. Notice that if I divide by a negative, what once was pointing to the left now has to point to the right. So my solution is going to be x is greater than 6. So I'm going to just write down some numbers on my number line. I'm going to say that 6 is right here. It doesn't really matter. I can put it wherever I want because they haven't labeled this for us. And then I'm going to put an open circle at 6 because I don't have a horizontal line underneath my inequality. And since I have x is greater than 6, I have to shade to the right. Now before we move on, I want to take a look at one direction that was given in both numbers 9 and 10. They say check your answer at x equals 0. What this means is think about if x was 0 in the original inequality. So in the original inequality, if I plugged in 0, I'd have negative 3 times 0 plus 7 is less than 46, which just leaves me with 7 is less than 46. Is that true? It is true. Okay? So now, how about with the solution. If I put 0 into the solution, what do I get? It should say 0 instead of x greater than negative 13. Is that true? Yes, 0 is greater than a negative number. Okay, so that means that our solution matches with our original inequality. They're both true when x is equal to 0. So now let's see about our solution for number 10. For number 10, if you were to put 0 in for x in the original inequality, that means that you would have 5 times 0, which is 0, plus 7, which is 7. So at x equals 0, you would get 7 on the left-hand side, and then on the right-hand side, you'd have 8 times 0, which is 0, minus 11. 0 minus 11 is negative 11. And I'm just checking things, so I'm just plugging in numbers. That means that the inequality sign would still be as it was in the original inequality, less than. So now, what do we think about this statement? 7 is less than negative 11. That's false, right? A positive is not less than a negative. Okay? Doesn't mean that anything's incorrect yet. I'm just recognizing that at x equals 0, our original inequality was false. So now let's see if the same thing happens with our solution. With our solution, it says x is greater than 6. If I put x equals 0 in there, what do I get? I get 0 for x greater than 6. Is that true? No, that's also false. So the fact that both inequalities, the original and the solution, were false when x was equal to 0, it means that our solution matches with our original inequality. Just like in number 9, the solution and the original inequality matched when x was equal to 0. Just gives you a way to test to see if your solution is correct. So now that we've learned some things about solving inequalities, let's look back at our examples 1 and 2 from earlier in the lesson. This time we want to solve the inequalities using this algebraic process that we just learned about. So number 11, refer to example 1. Mr. Lawson bought a car for $16,000. Each year, the car loses some value. The car's value is represented by W. The number of years after Mr. Lawson bought the car is represented by X. The equation that gives the car's value after X years is W is equal to 16,000 minus 1,500 X. We want to know when will the worth be less than 11,500? So really, that just means take the worth of the car, which is 16,000 minus 1,500 X, and we want that to be less than, so we use the less than symbol, 11,500. That's the inequality in part A that could be used to answer the question, when will the car be worth less than 11,500? So now part B, solve the inequality. Make sure to check that your answer matches the answer that we wrote down in 1B. So if I start with 16,000 minus 1,500 X is less than 11,500, remember we want to get X by itself. So I'm going to do addition or subtraction first to move any constants around. So the 16,000 is a constant. It doesn't have an X attached to it. Notice that the sign in front of the 16,000 is a positive, which means I have to do the opposite. So I have to subtract 16,000. And when I do that, all I'm left with on the left-hand side is the minus 1,500x, that's the negative 1,500x, is less than And then 11,500 minus 16,000 is negative 4,500. And now I need to divide by negative 1,500 because I want to leave the x on the left-hand side. So if I divide by negative 1,500, remember that means that the x stays where it is. I'm just getting rid of the number by the opposite operation. Negative 4,500 divided by negative 1,500 is 3. And remember, if I divide by a negative, I have to switch the inequality symbol. I have to reverse it. And notice that this says x must be greater than 3. X is greater than 3, which means if x is the number of years, so the number of years have to be more than 3. So when will the car be worth less than 11,500? When the number of years is more than 3. And if we go back to question 1b, that's what we said. Any time after 3 years, when the number of years is more than 3. Okay, so now, number 12. Refer to the other example. Ms. Nizami loaned $10,000 to a startup company. The terms of the loan read that the amount of money, capital A, the company owes at the end of X months will be capital A equals 10,000 plus 120X. We want to know when the amount of money that the company owes is less than $10,600. Part A, what inequality could be used to answer this question? So again, we want the amount of money, which is A equal to 10,000 plus 120x, to be less than 10,600. So that means the amount of money, 10,000 plus 120x, we want that to be less than 10,600. So then part B, we want to solve that inequality. So I'm going to use the same steps that we just did in the previous example. I'm going to subtract first because I want to have the 120x left alone on the left-hand side. So I have to subtract the constant 10,000 from both sides. That leaves me with 120x on the left-hand side is less than 10,600 minus 10,000 is just 600, and now I have to use division. Divide by the 120 because that's the opposite of 120 times x. That leaves me with the x all by itself on the left-hand side. I'm dividing by a positive, so the inequality symbol stays in the same direction. And then 600 divided by 120 is 5. And notice that your solution here is x is less than 5, which is the same solution we had earlier. We needed the number of months to be less than 5. All right, so to finish up this lesson, we're going to look at solving inequalities with a graph. We have seen that solving inequalities is similar to solving equations. There are times when solving inequalities is not like solving equations. One important exception occurs when we multiply or divide by a negative number. That's when we got a difference. When we multiply or divide by a negative number, we have to reverse the direction of the inequality. Another way to solve an inequality is with a graph. One way to solve inequalities with graphs is given here. First, write a formula for each side of the inequality. Second, graph each of those formulas, essentially equations. 3, extend the graphs of each formula as needed to find a point or points where they cross, or make it clear that they don't ever cross. Where they cross is also called an intersection. Number 4, use the graph or a table to estimate the points at which the formulas cross, or write and solve an equation to find the crossing points. 5, use the graph to see the intervals for which the inequality holds and express this in words. That's going to be your solution, essentially. So we're going to try this with what is called a quadratic inequality. What we were looking at before were linear inequalities. So this is going to be a little bit more above that. So the situation that we'll look at is, imagine that someone throws a ball straight upward with a velocity of 128 feet per second. Velocity is the same thing as the concept of speed. So they throw this ball up in the air and it has a certain speed to it, 128 feet per second. The person throws the ball from the top of a tower which is 144 feet high. Let x equal the number of seconds since the ball was thrown, and let y equal the height of the ball at time x. The model for the height is y equal 144 plus 128x minus 16x squared. When is the height of the ball greater than 336 feet? We will solve this inequality. Y is greater than 336 because y is measuring the height, and we want that to be greater than 336 feet. The graph of y equal 144 plus 128x minus 16x squared is shown below. And if you're wondering which graph is it, just think of when you throw something up in the air, what comes up must come down. So it's this thing that looks like the motion of throwing a ball in the air. And even if it's thrown straight up, the reason why we have this thing that looks like an arc is because we are measuring the horizontal axis as time. So over time, the ball is going up, but then it's coming back down. So the horizontal axis here is time, the vertical axis is height. And so this curve is the equation y equal 144 plus 128x minus 16x squared. And then also notice that there's a horizontal line. We've saw horizontal lines used before. They are just y equal to some number. In this case, you can see that it's somewhere between 300 and 350. That's the 336 that they're using. So when you go back to those steps on the previous page, they say write a formula. So we've got that for each side of the inequality, and then graph each of those formulas. There's those two graphs. Extend the formulas as needed to find a point or points where they cross. So notice that these do cross at 2 points. So now let's take a look at the questions below. Number 13. Let's find the solution using the graph. After the ball in part A is thrown from the tower, how many seconds will it take before the ball passes 336 feet? So notice before this graph crosses the horizontal line that's drawn, it isn't above 336 feet. But the moment that those two graphs intersect at the first red dot that I have, the ball is now about to be above 336 feet. So how many seconds will it take before the ball passes 336 feet? Notice where they intersect. Follow that down to the horizontal axis. 2 seconds. Part B, does the ball pass a height of 336 feet high more than once? Yes, there's a second intersection point. And where is that? Follow that down to the horizontal axis. It's at 6. So yes, again, at 6 seconds. So then part C, when is the ball more than 336 feet above the ground? Well, that has to be between those two intersection points, right? Because the graph, you can see, is above the horizontal line that was drawn for any time between 2 and 6 seconds. So, when the time is between 2 and 6 seconds. You can actually write this as what is called a compound inequality. X stands for time. You would like that to be between 2 and 6, and then you have to connect those with inequality symbols. This says 2 is less than X is less than 6. And that's your solution to this inequality. So that finishes this lesson, and the secret word for this lesson is seconds.